Good morning, everyone. This is Xa Talk Show. You are watching. Today is 2019, November 19th, Tuesday, noon in the afternoon. Well, noon, not afternoon. Noon is not afternoon. So we have a lot of people. Thank you guys for coming. And that is the prelude. That is the prelude of prelude. So let me stop this video and let's see what's in the chat. And I'm thinking today we are going to do either miscellaneous live coding of Emacs Lisp, or let's do JavaScript plus SVG live coding, doing a live rotation of platonic solids. And if we're gonna do JavaScript, that's going to take 1 hour, or 40 minutes, something like that. So it looks like something like that. We did this like 3 days ago, and we are going to continue doing this. So if we are going to do this, I'm going to do live coding and kind of explain how you do it. So either that or Emacs Lisp, because the JavaScript one will take like 40 minutes or more. So we cannot do both. So you guys, so it depends on what you guys want. So type what you like, just type it, and we'll see how many prefer JavaScript or Emacs Lisp. For the Emacs Lisp, I'm doing live coding of miscellaneous Emacs Lisp commands and plus explanation, things like that. So today, what is it gonna be? Type it, okay? Type it in the chat, and let me read the comments and let's see. Today is a fine day. Tuesday. Tuesday is weekday. People are working. Good morning, Bart. Good morning, Emily. Good morning. Thank you. You too. Time to make a hot chocolate. Oh yeah, hot chocolate. So I'm going to drink my power drink. My power drink, as usual. This is energy drink. Okay, energy juice. And today I have the juice of choice is grape and apple, basically. 100% juice, no sugar. No sugar, okay? Natural sugar in fruit is okay, but don't drink sugar, okay? Sugar do bad things to your body. And cheers. And guys, join Discord, okay? Ignore Bart, okay? Bart is keeping talking about uh his thing. It's not gonna work, but move on. Move on. So Discord. Let's see. Where are we? What is this? Okay, Discord. Where is it? Okay, here. Discord. Okay. So Emily is apparently Emily is learning Loshibang, and she's got this Loshibang book. Okay. Anyway, that's not today's topic. Let's see what you guys. So Emacs Lisp or JavaScript. Cheers, cheers. So let me read the comments. I have to magnify the font. So getting on. So look at the UK person spells cozy as cozy. Okay, okay. Let's go up. See you again. Thank you. Too hard to catch you. You too hard to catch you. Hola. Hola, time to make a hot chocolate. Okay, so look at UK person, cozy. Emily's got a cozy home. Yes, she does. Okay, so let's start to talk about something interesting. So some people should answer your Emacs questions on the forum. What? Now my hot chocolate frothy mud. So I decided to rename Elite XR Club. Okay, Bart's got forum. Okay, let me. Well, Bart has. Okay, Bart, what is your forum written in? Okay, what? So it's. I mean, what language? I mean, what? It's XRD dot. Wait. It's xartalk.ml. Stupid thing. Close Twitter. xartalk.ml. These domain names, that's no good. Just use .com, .org, .net. .ml is no good. But once you start already begin it, then it's no good to change. Okay. So ML is what? What country is ML? So guys, JavaScript. Okay. So I guess let's do JavaScript then. Just one person saying that. Okay, so anyway, Bart's got this xartalk.ml. That is before I had Discord. Bart is, he planned to do this. It's supposed to be, my Xartalk show forum, so we can go there. But before he announced it, I already went to Discord, so this forum is kind of hanging there. So this is not BB. So what is not BB? So Bart, like, what technology is this? So anyway, if you guys like to use this, go there, join Bart's forum. So Bart, I'm not gonna work. Give up Linux rules. Go use Linux. Okay, Bart, what technology are you using? Like, what is this? What language or what framework is this? Oh, your browser does not support JavaScript. Okay, let's turn on JavaScript. Payful.com. Oh, ML is free. ML is free. But what country is ML? When I got enough people, I will improve and work. It's not likely you get a lot of people here. Because what? I mean, really, because I'm running. It's not likely. Like, if you do a talk show and you are the focus of attention, then you create your forum, then people go there. But because I'm doing it, and I already have Discord, and your forum is great, but it's not going. It's just not going to work. Okay, so let me actually. We should start to talk about JavaScript or Emac. So JavaScript, I guess. Because you see, I don't have a schedule. It's like random. So every time I have a problem of what to talk about, I don't have a schedule. I don't have a plan. I don't have a schedule of topics. Usually, that's what you should do if you are doing YouTube, and if you want to grow your audience. Because people in modern society, they need to they don't have time. And But that's something I have to do, but that's just, it's not happening, at least not now. So every time I do a talk show, I have to choose a topic, and usually I need the topic to be something of interest to the people currently present, because then people talk about, because if I'm doing JavaScript, and if most people don't know anything about JavaScript, then it's gonna get cold. But on the other hand, if I'm doing Emac Lisp or something else, a lot of people are interested in it. Then people, like, you guys chat about it. Then I saw the messages. Then it becomes more busy. So anyway, unsure. I'm unsure and uncertain. That is the story of my life. Unsure and uncertain and undecided and undecidable. the, the fundamental theorem of mathematics. Undecidable. Everything is undecidable. Well, if something is decidable, then it is not interesting. You are working in a system that's not interesting at all. If you are working in a system that's interesting, then then things are undecidable. Uh, you owe me. So what? I don't owe you. Okay, okay. So wait, what? I don't owe you. Hello, beautiful people. So payfor.com. Okay. But so what is the interesting question is .ml. You know what? So what is .ml? Like what country is it? Why is it free? .ml domain name. So .ml domain name. Okay. Well, actually, I'm starting to talk random. So Emac list for JavaScript. So Alan, so let's do JavaScript then. I know Alan is interested in JavaScript, and then since we have another guy, oh God, I got get better with reading the messages and not keep scrolling up and down. So everything is falling apart. Uh, no plan, no schedule, no nothing. It becomes so, you know, the way my YouTube is going is just random chat, like random chat to Xa. JavaScript. Okay, let's do JavaScript. So let's do that then. Let's see how long I've been talking. 11 minutes. Okay, so JavaScript. So let's go to show JavaScript, and we are going to add some. Let's see, poly. Okay, poly and Xa start command log mod. So on the left window, for you Emacs users, you can see all my Emacs command calls on the left window here. Okay, and we are going to show you this one. So show in Chrome, open in Chrome browser. Okay, so we got, now it's improved since last time, because now it's rotation of the polyhedra, yet you don't see the background, so it's not wireframe. So this is improved. You can rotate it, and it needs a lot improvements. You know, it really needs a lot work. And one feature I wanted to add is mouse rotation. Now I don't know how to do that yet, because I mean the part I don't know is how do you control. So if you want live rotation with a mouse, how do you, like, what event is it in JavaScript? How do you, like, how do you do it basically? So you know, the rotation is interesting because uh, like the user interface of mouse rotation is very interesting, because I'm going to explain. But however, that's not related to JavaScript technology. It's related to user interface design. So let me explain that. Yeah, so let's just talk about whatever, but we're gonna focus on JavaScript today. So rotation is interesting. Why? Because let me find the article. Okay, so you have this Space Navigator. Okay, Space Navigator. This is a great device for using with Google Earth or any kind of 3D rotation thing. Google Earth, Blender, any kind of 3D software. This is a fantastic input device. So you can see, you can, you know, originally this device looks like that. This is like 20 years ago, year 2000. It looks like that. It was used in NASA, you know, space control, space shuttle or whatever. It was called Spaceballs. So what is it? It's like a joystick. Okay, it's like a joystick. Plus, you can also pull it up or push it down, or and plus you can also twist it. Okay, so the easiest way to understand what this does is, you know, it's basically just a joystick. Plus, you can pull it up, push it down, or twist it. That's it. Okay, that's it. So originally it was designed for NASA, something like that. Okay, and eventually it becomes looks like that. So I have a videos here. So if you go to my website, let me show you guys. So talk show, today's talk show. Let's paste the link here and magnify, and before we do anything, hold on a second. So we gonna get the URL. So URL, you guys can go argo at it and buy it. Buy it. I get $1 or something, 50 cents. Buy it on Amazon. So, okay, so the space navigation. So I'm going to talk about why the user interface of rotating 3D object. There are quite a few variations that's interesting to discuss. And what I was going to do. So I need to go to this in Chrome. Okay, so let's go to in Chrome. Oh yeah, so click on that. So this Space Navigator is great for 3D software. For Google Earth, so this guy is reviewing it. Okay, so he's doing a review, so you can see how it works. And I tried it once when I went to Google. I have friends at Google. I have friends at places. So when you enter the Google building, they have a giant Google Earth, like huge, humongous screen. Then you have this device in front, so you can, it's very fun. I love Google Earth. Google Earth is such a fantastic thing. Okay, Kasali Google Earth 101, Geography 101. Google Earth is like if you are a gamer, young people. Wait, okay, I got a few articles about this. All very interesting, of course. Now, Google Earth. Let's see, Google Chrome, Google Earth. Okay, so let's close that. And Google Earth, you can also use it as a flight simulator. You can do that. I don't know they still kept that feature, but at least 5 years ago you can. So I tried it, as a flight simulator. But anyway, so Google Earth is very interesting. So a lot of gamers, you play games, right? Oh, video games or shooting or whatever, driving. And Google Earth itself is kind of like a game. So instead of playing games, you play Google Earth. You explore the vast uh, places on Earth. You can see so many things. You can spend your whole life on Google Earth, literally. And so Google Earth. So this device is very good for Google Earth, and you go buy it. Okay. Now the next thing interesting I'm going to talk about. So one topic leads to another is this thing. Okay, let me show you. Math models of 3D input control. Okay, so this thing is gonna be, we're gonna talk about this. Is very interesting, but it'll be 10 minutes. Models of 3D input control. So let's see what's the comments. Uh, I resent my polyhedra rotate. Yeah, so I was talking about we are going off a tangent, but the rotation in JavaScript. So we are talking about, first of all, I was going to talk about the user interface variations for doing 3D rotation with mouse. That is what I'm going to talk about, and that topics then relates to the math models of 3D input control. Okay, that's related. But then before that, I was going to talk about how do you do the in JavaScript and DOM. How do you actually code it? That is, the technology. So that's another thing. Then you have the math aspect of rotation. Then that I know. So Alan is working in JavaScript. Alan that's his job. Alan's job. So I asked Alan, how do you do that? So he actually has a page that showed it. Where is it? And let's see. Uh, I think I have it. I had it here. Okay, well, here's another one, but let's see. So he implemented mouse rotation. So uh, then did you scrap that one? How do I math polyhedron rotate? I think did you scrap the old one where you oh hello beautiful people, thank you for the super chat. Putting money where my mouth is. Uh, so oh god, where is the comment? But anyway, Alan did a mouse rotation. I haven't got time to look into the code yet, so I'm going to look into and grab his code. I'm just going to grab whatever the part I want to know. But anyway, so that so let me talk about the 3D rotation, the UI aspect. Oh, by the way, before I mention that, before let me also mention. So there is a OpenGL. Of course, there's is this OpenGL technology, which so you can use JavaScript 3.js framework that allows you to program 3D object like a game, 3D object using OpenGL via JavaScript. So I try to learn this a few, like one time, but every time I learn OpenGL or WebGL, it always becomes so complicated, like 1,000 lines of code just to do a rotating cube. Meanwhile, in Mathematica, it's one line of code, and in JavaScript, it's 50 lines of code. Okay, in fact, I can show you Mathematica. Okay, is Ztron crazy? Part is Ztron crazy here. So in Mathematica, here's what you do. We are digressing, but in Mathematica, here is what you do. Okay, so I can type it. Okay, so cube one cube. You give two coordinate. Let's say -1, -1, -1. I think my syntax may not be correct because I haven't been coding Mathematica for about 10 years. But cube graphics 3D, okay? Then you put cube inside. Then you just do. So you paste that in Mathematica. It'll show a cube, okay, with where the corners are -1, -1, and 1, 1, 1. That's two opposite corners, I think. Mathematica. But if you want to rotate it, you can. I think you can already rotate it just by default in later versions of Mathematica. But if you are not sure, you can say manipulate. Okay, manipulate takes two arguments. Okay, and the first argument is the graphics primitive. Then the second argument is what variable you want to change. So I don't remember the syntax, but it's something like 1 to 10. So x from 1 to 10. So you can change. So here's what you do. Okay, so you add ViewPoint. Now I don't remember this is the correct syntax, but this is something like that. So ViewPoint x, let's say x 10 10. So that is it. So let me show you that. So this is the Mathematica code for creating a live rotation of a cube. So you say graphics 3D, and inside graphics 3D you give some graphics primitive. Every such as cube or triangles, you just give the vertices, the coordinates. Then you say viewpoint. Now I'm not sure this is the correct syntax. Maybe it's some other thing, but or you say rotation. Okay. Then you give a perspective, like where you want to look at the thing. Then you wrap it around manipulate. That will generate an interactive user interface with a slider. So you grab the slider, that will change the value of x, which in turn change the viewpoint, so you can see the rotation of a cube. So that's Mathematica. So that's how many lines of that? 1, 2, 3, 4. 4 lines, okay? Or in Mathematica, the entire thing is one line, so it's just one single line. Now in JavaScript, where is our JavaScript? So let's go to JavaScript, poly. Okay, so I got several versions. So view in Chrome, this is an earlier version. So there you go. So in JavaScript, how many lines is that? That is, let me magnify, 200 lines, 280 lines. Okay. Now I remember I tried WebGL. That's 1,000 lines. Fuck WebGL. Fuck OpenGL. Fuck the low-level programming nerds, the C and C++ people. Excuse me. The programmers are they are nasty. You know, so I don't. Well, to be fair, you know, they are not. Yeah, but you know, this is Xa Talk Show. The type of programmers, the hacker types, they are always. Anyway, the reason they are like that, because different perspectives. Because the hacker types, typically the hacker types, like they talk a big talk on Hacker News, these type of people, they typically their interest, their perspective on computer science is that they, you know, they the way they are like that, they always like to talk about, you know, C++, memory references, int float, you know, that crap. They are like that because they view the, you know, computer science from the machine manipulating the memory, that perspective, which is necessary and perhaps the proper perspective, because that's what you really need to do, you know, to get the whole thing to work. You have to know the CPU, you know, how you know how it works, the memory, the efficiency there, then the low level code assembly, then see, you have to do that. So that's typical, you know, the hacker types of programmers, you know, that's their perspective. Meanwhile, they know nothing about mathematics. They don't know nothing, but they adore mathematics. Like all the hacker types, they regard mathematicians as God. Like they, oh my God, this is getting into a tangent, a massive tangent rant. You know, so they are like that, you know. Meanwhile, they adore mathematicians. Meanwhile, they know nothing about it. They like to chalk up, like they like to use math jargons everywhere they have a chance, like the Haskell idiots. They are like saying category theory every day. Category theory, monads. Meanwhile, they what they know about category theory is shit. That it's like misleading crap. That's what the Haskell programmers talk about every day. You can see it on blogs, on Twitter, everywhere, on Hacker News. Now remember, here's a takeaway. Every time you see a Haskell programmer talk about math, Xa says treat it as entire garbage. Okay, don't even pay 1 minute to it. Entire garbage, like misleading crap. Like you can verify this by asking any mathematician. Okay, in fact, more generally, whenever programmers talk about math, treat it as entire fuck. Okay, that's these programmers, these hacker types. But however, when they talk about C++, operating systems, kernels, okay, that's good. Okay, that's good. But anyway, so my problem with them is that, you see, I came from a math background, so of course, I also have my opinions on programming languages, but my perspective don't mesh with theirs, you see, and they don't see my perspective because in their entire life, they have never seen one single line of math-oriented programming language, such as APL, MATLAB, Mathematica, Julia. Okay, these are math-oriented programming languages. I have articles on that. Just search for solid math-oriented programming languages. So these typical programmers, basically, I'm talking about the hacker types. Like they tell you about programming styles, what you should do, how you should indent, how you should more than one way to do, Perl style, the Perl code, or Pythonic. Each language, they have their terms, like Pythonic. The fuck. Then Lisp master, or whatever. Each group has their like particular jargons for your code being conformant to their particular thing. Anyway, these people. So what was I talking about? I forgot. So these people, these the hacker types. That's the type I'm talking about. Who are pretty loud, and their opinion typically are the establishment. They tell you if you don't conform, they think you are no good, and if you are loud, they think you are a troll. That's what happens with these people, hacker types. But they don't, you see, they don't know math at all. In their life, they have not even. I mean, they might have seen one lines of Mathematica or MATLAB, especially today because of the data science. They might have seen MATLAB, R, the language R, or Julia. Some of them start to do that. But basically, vast majority of these hacker types, fuck, they've never coded seriously, in any of these math languages. So my opinions don't usually mesh with theirs, and whenever they talk about how array should be, array. One of the most confusing things in computer languages is these jargons: array, list, or this kind of, this basically captured by array or list. List usually refers to nest, refer to linked list, and array is anyway. So and one of the thing you can see, one of the good example you can see about this is that these type of hacker types, when they like to say, so one of the example that illustrate this whole thing about the programmer hacker types of programmers versus anyone who knows something about math oriented programming, is that almost all the hacker types, like, I know most of you guys are probably that type, because we are in computing industry after all. We are not in, I'm not really a mathematician, so you guys are all the industrial programmers. So you people usually, oh yeah, so here's an example that illustrates the big thinking difference. You ask people, when should array index begin with 0 or 1. Okay, vast majority of programmers, they will tell you with with strong opinions. Okay, I have an opinion on this, and I have a strong opinion on this, is that it should start with 0. Most vast majority of programmers will tell you that, and they will insist, not just oh, I think maybe 0 is better. They will insist, these hacker types of fucks. Okay, am I right? So do you guys, most of you, think it should be start with 0, right? I think I'm correct on that. So I went off a tangent. Shit. I don't know if we should go back to JavaScript. Maybe it's too late. so these programmers, you ask them array, which should array index begin with 0 or 1. They will always say, with strong opinions, like they say it should start with 0. Okay, but if you look at all the math languages, they all start at 1. The real math languages, like Mathematica, APL, Julia, okay, MATLAB, for example, these four. These are math-oriented or scientific languages, which is entirely of a different nature than C++, Java, Python, Ruby, all of them, JavaScript, including Lisp. Now, including Haskell, okay, even includes Haskell. Haskell is this thing. Haskell is not math language. Haskell is not a math-oriented languages. Okay, despite these hacker fucks, Haskell Haskellers. They insist they're talking about math all the time. Meanwhile, they know nothing about math. So anyway, so array index start at 0 or 1. So actually, I talked about that in previous video. So solidly array index start at 0 or 1. Okay, you'll find that article. So what I'm saying, okay, so here's the thing. Here's the interesting thing. You see, these hacker types of people, they think array language. I mean, they think array should begin with at 0. Okay, they should start at 0, the index. However, when you ask them the reason, half of the time they will say because of mathematics. That's so extreme idiocy. Fuck these people. Fuck these people. Extreme idiocy. Okay. So, you know, you ask them. You know, when you talk about this online, like Hacker News, Reddit, or Twitter, you know, you see these programmers. They will say, you know, they will start to give reasons, right? Half the reason is like they think, oh, math. You know, if you actually respect mathematicians, they should start at 0. Okay, entire you know, it's just factually 100% factually incorrect. Okay, why? Because these programmers, they idolize math. Okay, so they, you know, the reason they think math should, you know, if you are a mathematician, you know, they think mathematicians should want array start at 0 is because 0 is somehow the more dramatic number. You know, the like the Unix people, you know, the fuck Unix philosophy. Like they think these hacker types, they always prefer something more difficult, more esoteric. That's typically the case. So they think mathematicians, you know, in math, 0 is actually, you know, in human history, in history of math, you don't have 0 in the beginning. You have, you know, 1. 1 is natural, like 1, 2, 3. Then, you know, later on, you have more abstractions. Then you started at 0. Then you started to have negative numbers. Then you started to have complex numbers, things like that. So 0 is the more dramatic between 0 and 1. So that's why these programmer idiots, fuckheads, they think they, you know, array should start at 0 because they idolize math. Meanwhile, they are completely wrong. The other reason they think array should start at 0 is because C, the fucking C language, and their reason is false too. They think they think they should start at 0 is because, oh, memory addresses. Therefore, when you start at 0, then you can add memory addresses, things like that. So therefore, it should begin at 0, which is factually incorrect too. You know, so I wrote an article here. You can read later. So let's copy to my you know. Okay, today is one giant rant, I guess. Oh well. Where is my Ksa Talk Show page? Let's go to Ksa Talk Show page. Where? God. Ksa Talk. I don't know if I'm losing my audiences or if I'm gaining audiences. Usually, if you talk drama, you actually get more people watching. So this is Mathematica code. Okay, Mathematica code. In fact, my Mathematica code, I'm pretty sure it's incorrect. If you run it, you'll get syntax errors. But basically, it's that. So anyway, array languages. Array should start at 0 or 1. So these hacker types of programmers, their reason is wrong too, because there is this guy, you know, this guy, Mike Ho, or Mike Hoya. How do you pronounce his name? He did research into the topic, and so he dig up the reasons. He looked into why does C begin with 0 in the first place. You know, why does C didn't begin it. C followed from C study, which is the BCPL, you know, language, BCPL, because BCPL was starting with this 0. Okay. But what's the ultimate reason? I mean, who began with zero in the first place? Because back in those days, now you have to read his article for the details, for the historically accurate detail. But I'm just going to tell you my reason, okay? Because back in the days, you have mainframes and you have punch cards. You don't have like today. You have punch cards. You program offline. You make the punch cards, then you insert them to the mainframe. Billions of dollars. To process it. Then it began at zero because some IBM executive, the boss who owns the machines, he needs the machine to run his yacht races, to compute his yacht race score or something. Therefore, it began with zero, the array index. Oh my God, what a show that is! Okay, now I don't know where I am. Now I don't know if I should go back to JavaScript or it's all entirely screwed up. Uh, Indeed, love comments. Interesting. What is this? Oh, I don't have time to look at that. So let's see how long have I been talking. Uh, Chat revenue. Okay, 4.3. It says chat revenue. Thank you again, beautiful people. 40 minutes. So I've been talking for 40 minutes. So let's. Yeah, I don't think we can properly start JavaScript today. So no, I'll do another one then. Another video. So anything else? What should we? So so do you guys have counter arguments to my arguments, or do I make sense? At least do I make a little sense on my rants about hackers? About their perspective. Why I always have, why they call me a troll. Why I always have problems with their opinions. Do I have at least make some sense? Because my life is known. My accomplishment in life is a troll. So is a troll. And online you argue with programmers, it's going nowhere. It's like I cannot go anywhere. There's no constructive, there's no, at least you hope to establish some way until we find out where we disagree. But typically that's not happening online. Typically, like, after you argued for days, you don't, like, there's no, and that's a case with online arguments. It's religious arguments like Emacs versus Vim, or Common Lisp versus Scheme, or Python versus Perl. Is kind of like that. Okay, so that's a giant ramble. So let's see where I am, and let's see where I am, and let's see where do we go from there. Uh, so let's read the comments from the bottom. So Alan says, I would add that hacker types are trapped in a particular model of the world, but this sort of behavior is very common across many kind of subculture. Yes, indeed, that is true. So I've been looking. I tends to be. I always wanted to look at the whole historical human perspective and see what's going on. So, for example, if I have disagreement with hackers, I try to look at just exactly what's going on. Like, am I just complete bizarre, crackpot, or I don't think I am. So but what is wrong is are they so anyway, so part of it, so yeah, it's true, it's culture, it's subculture, and largely culture and subculture. So that's why you have these hacker types. They have a particular way and habits. This convention. That's what they are. And then different culture and different subculture, they are obviously different. That's why they are subcultures. And the other reason I think has to do with it is also corporations. Corporations, the programming industry, of course, it's evolving around corporations. It is the corporations that make things move. Money, basically. You are a programmer, you work. You have to work. Most programmers have to work in a company. The corporations, they make money, and it is money that makes the corporation survive. So money has a lot to do with it. So money creates corporations, come and goes, and many corporations die and new comes on. And corporations, because of money, they evolve around it. They have to make ways, or many of the habits or the way you see things in programming is due to of complex reasons. It's due to how the corporations are run. What makes money. Their products. That is why. So that I think that has a lot to do with it as well. For example, why is C to this day so successful? I mean, well, so at least so popular. Why is C so popular? Why is all the CPUs Intel? It's so convoluted, but yet it's like the number one, CPU design. Why? Well, because backward compatibility, and that is because corporations. If you eliminate backward compatibility, then people don't want to adopt, for many reasons, natural reasons, habit, people don't adopt, then you die. So that is why JavaScript is backward compatible. So we have 20 years of garbage in JavaScript. The JavaScript people, you talk to them, the JavaScript, committee, they are creating the ECMA 2015, 16, 17, 2019, every year. You think, if we are all just programmers, if we have nothing to do with corporations or anything, we can just design, okay, in 2020, we are going to have JavaScript that eliminates all the garbage, 20 years of, baggage, then it's going to be good. But once you talk to them, they are not going to do that. You think they are just nerds, but they have many constraints, and because most of them actually work for corporations. It is the Google, Facebook, Microsoft. They are putting the money into you, and into this committee for JavaScript design. And you need membership. Like corporate sponsored membership. Money is talking. And also, again, history. You can't just eliminate compatibility, because then all the browser break. Many reasons. And in the same way, back to our the other topic, we were talking about the origin, the array index starting at 0 or 1. Okay. Now in math communities, it's always 1, because 1 is simply better, easier, more human, more natural to work with, especially when you have matrices or tensors. Tensors is essentially like nested matrices. So a matrix is like nested array. Okay, tensors is like more nesting of array, so higher dimensional nesting. So that's tensors. So in math they started with 1, because if you begin with 0, then you have nesting. Then becomes very unintuitive. Like it's hard to find specific array indexes. The tensor indexes. That's why in math they start with 1. But again, in computing, you have to deal with habit. Most languages, they all begin with 0 now. Well, at least the industrial programming languages. Python, Perl, Java, C, C++, C Sharp, Haskell. There's a bunch of crap. They all start with 0. So there's the habit going on. So when you have a new language, let's say someone invented a new language, and suppose me or you want to be popular, then when it comes to decision about array index, where should it begin? even if you think it should start at 1, but you can't be sure, because if you start at 1, you will know for sure you will lose people. You will lose people because people are habituated with 0. They don't want, and they have lots of misconceptions, like I talk about. They think their reason for starting at 0 is all basically factually incorrect. But there's nothing you can do. They already believe, the mass, billions of people, they believe that already, which even if it's false. So are you going to like fight that? It's hard. So if you are going to create a new language, you are probably going to, one, based on the C syntax, okay? Even it's the most the most crap syntax possible. But that's the way things are. If you start with some other syntax, people are not going to like your language. Then your language is not popular, then you die. Nobody uses your language. That's a fact of life. And then same thing with array index. You're gonna start with 0. So that's a problem. That's a thing. So maybe that's it for today. So tab or spaces. Oh my god, that's another topic, of course. Solid tab versus space. I have an article on that, and not just one article. I have more than one article on that. And that is, that's a big topic. I'm gonna talk about that for hours. Uh, okay, so I think maybe that's it for today. So that today is just that. Let's see, live streaming, 17 people watching, 4 likes, fantastic. Like it, like it, everyone, like my stuff. 51 minutes. Okay, so no JavaScript, cultural revolution, destroying the venerable odes. Convoluted DOM. Yeah, DOM is the massive pain in the ass. DOM is, web programming, okay? Not just JavaScript is the worst crap possible, even with today's, 2000 ECMAScript 15. But then you have DOM. My God, DOM is, and also it's impossible to understand DOM. It's really, I tried. If you really want to know the technical details, then okay, so trackball versus mouse. Okay, that's another thing. Oh, well, we haven't finished talking about uh, what is the deal with the user interface about about 3D rotation. We haven't talked about that. So yeah, maybe we've finished that. Okay, so where is that? Okay, so 3D rotation about okay, so let's go to Brave and let's see. Okay, that's not here. Okay, then let's go to Google Chrome. I think it's here. Close that. Okay, so Google Chrome, they begin to show. Yeah, okay, they're here. So this is about this math models of 3D input control. Actually, there are two things about it. One is the math models of 3D input control, but the other thing related I wanted to talk about is the actual user interface variations about 3D input control, like when you want to rotate with the mouse. So let me talk about, yeah, so okay, so let me talk about the math models of 3D input control. This is not formal. Okay, this is not. It might be too big a word to say math models. But anyway, let me tell you what's interesting, what's going on. So when you use a flight control, okay, like flight simulator, So you fly a plane and you see these, right? And you have various controls. You want to typically you want you they call, each one have their jargons. Like in flight control, you have the pitch. So this is your airplane. So how do you? So this is your airplane. You fly forward. So you have pitch, which is whether you should go up, turn up, or turn down. Going up or flying down. That's pitch. Then you have roll. That is you rotate around the path you are traveling. So roll, you can roll right, and typically you will turn right. You can roll left. Okay. So that's roll. So pitch is turning like that. Roll is turning like that. Then you have yo. Is that right? Called yo, right? Yo is like turning that. You know. So I don't know if you understand me, but if you do flight simulators, if you play that, you know what I'm talking about. So that's one thing about uh, um, flight simulator. Okay. Now, if you are playing a 3D game, let's say some real-time shooter, how do you call that? Like World War II, how do you call that? Some of the names. Um, what's some of the names, guys? The games where you control a character, you going through, you hold a gun, you can shoot, you can look, and I, I cannot remember any names when I'm talking to people. Let's see. Doom. Okay, Doom. Doom. Originally, you have Doom. Then you have. Then you have Half Life. Okay. Then you have Half Life. Yeah. Then you have Fork. CS. Wait, what? No, that's not. Then you have the anyway real time shooter games. You go around. So basically, you control a character. So to control that, it's also 3D, right? So you have forward movement to control your character, forward, backward. Then you have a turn. You can turn your character left or right. Then you have strife, kind of like you don't turn, but you move your character left or right like that. Okay, so and so that's your moving your character, but usually you don't. Yeah, Quake is another one. Exactly. Quake. Yeah. So in those games you have several movements: going forward, backward, turn left, turn right, and strife. Kind of move your character parallel to the screen. So that's one thing. Then another thing is that if you can fly, well, that becomes like a flight simulator. Okay. Okay, that's one thing. Then let me tell you another thing. Panorama. Okay, so panorama is another interesting thing with 3D control. Now you know what you guys have seen panorama, right? Of course you have. So let's pick something. Let's say that. So here you can control so that you have different kind of user interface controls, but in here basically you can kind of rotate the whole scene. You yourself, you don't go forward, you don't go backward, but you can rotate the whole thing or rotate up and down. The whole scene. And you can, but some panorama you can also pan. They have a jargon, pan. That is, you move your entire screen. Um, move it up, like translate, move it up or down. So that's pan. Okay. So that's panorama. Panorama. Yes. Then another thing, which is also common, is when you are doing 3D modeling, like in Blender or in Maya. They changed their name over the past 20 years. So you have AutoCAD, Blender, you have Maya or whatever is the current name. So in those cases, usually you have a object. Let me show you. Let me show you. In those cases, you have a object that you want to rotate. It looks like okay. It looks like this. Okay, so here is the object. So typically you can rotate this thing. You can rotate right, left, up, down, or sometimes in an angle you rotate it. So we have all these different 3D kind of scenario where you want it all has to do with 3D, and it all has to do with rotation in some way. Okay, like rotating an object around its center, or panorama is kind of you rotate the scene kind of, or then you have pan, then you have a game, shooting game. You move your characters forward, backward, left, right, and strive. Then you have the flight simulator, yo, and that. So I'm thinking, all these things, can you somehow unify them? Uh, you know, like how do you think, how do you think them in some kind of unified way? Like, can obviously they must be, so that's a question to explore. That was what I was thinking. So obviously, yes, of course you can unify them. In fact, that's how, if you program them, that's what you have to do. So basically, doesn't matter which one it is. It's a game, it's a flight simulator, or it's a panorama, or it's a math subject you want to rotate. When you try to implement them, basically all of them have what happens is that you have a scene. Okay, like for example, this is a scene. This is a scene. This is what, like you have a 3D model of a 3D space. Then you have a camera. Now the camera represents your position of your eye. Okay, so basically what it amounts to is that you can move your camera forward, backward, left, right, or think of your camera as a bee. You know, you can also move your camera like a bee. You can move the camera in any path. That's one thing. Okay, you can move your camera in any path. But also, the camera itself can have different orientation. It can point up, down, or even backwards. So that's two parameters. That's the thing you control. Okay, so you can move your cameras up and down. I mean okay. So two things: the path of the camera. That's one thing. The other thing is the orientation of the camera. Okay, basically that's the two parameters that controls all the other different scenarios. Okay, so in the case of rotating an object, what happens is that your camera does not move, stays put, and the camera's orientation doesn't move neither. It just points to, it's facing an object. So when you are rotating the object, you can think of it as rotating the object, or you can think of it as actually moving the camera. So you are moving the camera in a way such that the distance between the camera and the object remains constant. So in other words, the camera stays on a sphere. And while the camera moves on the sphere, it always points to the center, the object. So that's how you think about this. Either you can think of rotating the object, the camera stay put, which is simpler, or you think of the object remains not moving. You move the camera around the sphere. So that's one thing. And if you want to zoom, that's moving the camera closer. Zoom out is moving the camera backward. So that puts the whole thing into one coherent thing. Which is, this is not rocket science. It's just, so I was looking at this, so I'm thinking, so that's obviously, so I found the answer. That's how you do it. That's how you think about this. So when it comes to panorama, what happens is that the camera stay put, but meanwhile the camera changes its orientation. The camera changes orientation. So then when it comes to a 2D game, I mean 3D game, then in that case the camera typically stay near the bottom. It can move forward, left or right or backward, and it also can turn, change the orientation, but it typically never goes up or go down. It stays on the floor. So once you know this, so the actual 3D model, then many of the kind of the UI, now you have a better understanding about the UI, about how it falls into place. So that is what I'm talking about. So this is about the math model of 3D 3D games, or panorama, or math visualization software, 3D modeling software, things like that. So you understand this model. Then the other thing now is about the user interface control. For example, in a 3D game, by convention, you use the arrow to control basically your camera movement. You use the mouse to control the camera's orientation. Like typically, when you look around, that's controlled by your mouse, the camera's orientation. Now, in a flight simulator, how do they do that in flight simulator? I guess similar, right? Yeah. So you use the keyboard to control the airplane path. Row, pitch, and yaw. Then you also use the mouse to control your view. I mean your camera orientation. So that's that. Now the other thing I want that becomes interesting when we are talking about rotating something for visualization, like in JavaScript. There are several ways to implement this. For example, I think in vast majority of 3D software, I mean math visualization software, where you visualize a object, usually they only have two rotational axes. So you can rotate the object around X, or you can rotate it around Y. So let me show you that. So that is the case with the polyhedron here. So let's go to. Anyway, I don't know if this is interesting, or I took too long to talk about this, and it becomes boring because people understand what it means already. So, for example, let's say a cube. Okay, so let's say as a cohedron. So I can press my mouse up or down. I mean my arrow keys up down. So that's rotating around the x-axis. Or I can press right and left arrow. It rotates around the z-axis. So there's only two rotation axes, y and z. Okay. But with this combination, you can orient the object in any way you want with just these two rotations. Now, if you are going to do the mouse, now I haven't done that, but if I implement in the mouse, I can do the same thing. So I can, for example, typically you hold down the mouse, you start to drag it, then you drag it to the right, and you release the mouse. Depends on how fast you release the button. That determines how fast it rotates. So it will, but the thing is now, so it will rotate in y-axis and also rotate in x-axis together, like you combine them into one. So that's one way to do it. Another way, typically, like okay, let me explain this way. When you have a like you go around, you look for math visualization like rotation. Almost never, okay, it is almost never the case where you can either press a button or use a mouse so that the whole thing rotates like that. Okay, it's almost never the case. But however, some software did that. So what I'm saying is that you see there are different ways to implement the UI. Like how do you want the mouse to work with the how do you want the rotation to work? For example, yeah, so actually there are quite a few examples I can explain. Like right now, you are seeing the way I do it. Okay, so I mean this is the way I do it. Now there are other software where, well, I actually it'll take a lot to explain when you talk about 3D things unless you actually show an example. Yeah, I don't have an example here, but well, I can just tell you. Maybe I'll try. Okay, so there are some software, for 3D surface plotting software where you can rotate the thing around the z-axis, then it'll keep rotating around that axis. Then you press another button. It doesn't work like the way I have, but rather it keeps rotating around that axis. So you'll just see it's like a top. Okay, it's like a top. So you can start a top, it will rotate. Then you can tilt it. It'll just keep rotating like that. You see what I mean? It doesn't like start to flip like in some weird way like what I have here. Like the one I have here. Let's try cube. You see, I rotate. I rotate right and left, and I rotate. Then it flips in a weird way. You kind of lost orientation. On the other hand, some software, math software, you just rotate like a top. Doesn't matter how you rotate, it's still, it shows like a top. You're just viewing it from different perspectives. So that's what I'm talking about. You have quite a varieties of trying to do the rotation UI for rotating a object. Okay, that is what I'm saying. So which one is better? For example, in Blender, so Alan, you use Blender, right? So what does Blender do? I think Blender typically they would do just like the way I have it. You rotate around two axes, or so I don't know what Blender does. So anyway, that's think that's what I have. That's what that's today's talk show, guys. Uh, Okay, I'm gonna read the comments and for 5 minutes, and that's it for today. 1 hour and 12 minutes. Are you modeling a potato? Yes. um, why are the potatoes in the room smaller than your eyeglasses? What potato? Oh, those are not potatoes. Those are pears. Okay, you guys. Okay, let me demo. The demonstration of perspectivity. Okay, these are pairs. Okay, I can still juggle. God, shit. The juices are coming out. I don't want to drop them. Drop them. They are like juice. So those are pears. Delicious. So that's it. That is it. That was delicious pears. Juicy pears. When I drop them, the juice comes out. So, and that's it for today. Thank you guys for coming. Uh, I'm going to read the comments for a minute or two, and that's it. I don't think there's much comments, serious ones, I guess. Uh, no JavaScript culture. Okay, so we did. I saw that. Good morning, Kathy. Good morning, Fitch. Now, Fitch, you are in Germany, right? Good morning, Kathy. To UK now. Roll count. Okay, roll count, guys. Nabby Young. Nabby is from California, or was it California, right? And Alan in California. California, the Great California. Emily in UK, and okay, I would read that hacker types are trapped in, yeah. So gaining more people. Okay, so Nabi Young, Ram Prasad. Hey, Ram Prasad, I have crossed the path to zero so far back. I think I will be confused. What? I forgot what that was. Ram Prasad, where are you from? Where are you from? Good morning, hello, beautiful people. Uh, bye, guys. Bye, guys. That is true. Bye, guys.